Hello guys, you are welcome to my YouTube channel. This is the introduction video tutorial for sample size calculation. Let's begin. In this video tutorial, I will be covering the introduction to population and sample, importance of sample size calculation, key terms in sample size calculation, basic steps of sample size calculation and tools used for sample size calculation. Now let's talk about population. Population is the aggregation of person, objects, or the elements over which the researcher have interest. It is a complete set of elements, person, or objects that possess some common characteristics defined by sampling criteria established by the researcher. It can be either target population or the accessible population. First of all, target population. Population which meet a set of criteria that is established by the researcher are the target population. The entire group of people or the objects to which the researcher wishes to generalize the study findings are the target population. Now let's talk about accessible population. Accessible population is the portion of the population to which the researcher has reasonable access. If all the target population are accessible to the researcher, then at that time the target population is equals to accessible population. Otherwise, accessible population is the subset of the target population. Accessible population may be limited to region, state, city, country, or the institution. Sample is drawn from the population through sampling process. There are two types of sampling process. One is probability sampling process and another non-probability sampling process. If the sample is drawn from the population using probability sampling technique, then the result obtained from the sample can be generalized into population. Now let's talk about sample. Sample is the subset of the population selected for the study. It can also be defined as the representative unit of a target population which is to be worked upon by the researcher. Now let's talk about characteristics of good sample. There are four characteristics. Good sample must be representative. It must be sufficiently large. It must be easy to draw and it must be efficient. Now let's talk about sample size calculation. Sample size calculation is the mathematical estimation of number of subjects or the units to be included in a study. How large the sample size should be? In order to answer that, we must go into two questions. What happens if sample size is too small and what happens if sample size is too large? If sample size is too small, then a study may fail to detect a clinically important difference, or the study may imprecisely estimate effects or the association, or the study may fail to answer the research question, or there will be the waste of input of the study participants, or it will produce a false negative result, as a result of which a study may disservice to the research by discouraging further exploration of the area. On the other hand, if sample size is too large, then a study requires more cost and more human manpower, as a result of which there will be the waste of more resources that could have been spent on somewhere else, and it will be difficult to maintain quality of data. So, sample size must not be too large and it must not be too small, it must be optimum. Sample size must be calculated at the time of proposal development so that optimum sample is collected. Now it's time for importance of sample size calculation. There are three importance of sample size calculation. First is to allow for appropriate analysis. Second is to allow validity of significance test. And last is to provide the desired level of accuracy. Next is the approach of sample size calculation. There are two approaches. First is precision based and second is power based. First, precision based. In precision-based approach, sample size calculation depends on with what precision do you want to estimate mean, proportion, mean difference, odds ratio, etc. In precision-based approach, you will specify relative or absolute error before sample size calculation. Next is power-based approach. In power-based approach, sample size calculation depends on with what degree of certainty you want to estimate mean, mean difference, proportion, or the odds ratio. Now it's time for key terms. Key terms that are helpful for sample size calculation are alpha error, beta error, power, and effect size. First, alpha error. It is also known as type 1 error. It is the probability of falsely rejecting null hypothesis and detecting statistically significant difference when the groups in reality are not different. It is the chance of false positive result. Second, beta error. It is also known as type 2 error. It is the probability of falsely accepting null hypothesis and not detecting statistically significant difference when a specified difference between the group in reality exists. It is the chance of false negative result. Third, the power of the study. It is complementary to beta error. It is the probability of true positive result. It can be defined as the probability of correctly rejecting null hypothesis and detecting a statistically significant difference when a specified difference between the groups in reality exists. Last one, effect size. Effect size is the minimal difference between the groups that the investigator considers biologically plausible and clinically relevant. Now it's time for discussion in steps in sample size calculation. There are 6 steps in sample size calculation. First step, identification of major study variables. Let us consider you are conducting a study on hypertension. At that time, systolic and diastolic blood pressure measured in mmHg may be your major study variables, or presence or absence of hypertension can be your major study variable. Step 2, determine the type of estimate. The type of estimate can be mean or mean difference or proportion or ratio. Step 3, find out the frequency of factor of interest. If factor of interest is rare like cancer, then more sample size is required, and if it is common like hypertension or diabetes, then less sample size is required. Step 4, that is decide approach, whether it is precision based or power based. In precision based approach, you need to specify absolute or the relative error. More the precision, more will be the sample size. In power based approach, you need to specify power. More the power, more will be the sample size. Step 5, that is, you need to decide the confidence interval. It is complementary to alpha error. Next is you need to calculate sample size with appropriate formula. Step 6, that is, after sample size calculation, you need to adjust sample size for population size, design effect, and non-response rate. Now, it's time for tools used in sample size calculation. There are several tools for sample size calculation. First one is nomogram. Next is ready-made table. You can use R programming for sample size calculation, GPower for sample size calculation, and Stata for sample size calculation. And finally, you can use several internet websites for sample size calculation.